So we're doing it on intermolecular forces and water. Now, one of the first, intermolecular forces is the dipole-dipole force. It's attractive interactions between polar molecules, and it has permanent dipoles, which is different from London dispersion forces, which are very weak and very short-range attractive forces between short-lived dipole-dipoles. So one of them has to force the other one to become a temporary dipole until the one that forced it to moves away, and then it just goes back to the way it was. It's just called dispersion forces for short. Third type of intermolecular forces is hydrogen bonding. It's a fairly strong dipole-dipole interaction, but it's still not as good as covalent or ionic bonding between molecules containing hydrogen and other very reactive elements such as nitrogen, oxygen, or fluoride. An example is water. You can see I've drawn a little diagram showing the connections. The little dotted lines are hydrogen bonds, as you can see. Now, moving to properties of water.
Ooh.
Okay. So the properties of water all happen because it has hydrogen bonding.
Oh.
So it can bond between the H molecule of one and the O molecule of another atom. Okay, so I'm going to be talking about two main properties, adhesion and cohesion. Adhesion is where it's a force that attracts particles of different elements. So that's an example is when water condenses and sticks to the glass. So as you can see, I drew a picture where it's sticking to the glass.
Nice.
And then cohesion is a force that attracts together the atoms of the same type of atom. So it's like when there's two water droplets on the glass and then they move together to form one big water droplet. That is an example of cohesion.
Okay, so I have the history of the intermolecular forces and water, and so I'm going to go over the scientists who discovered these things. The first one is Johannes Dietrich van der Waals. He was the first scientist to explore intermolecular forces in 1873. He came out with the van der Waals force, which he believed was only one force, but it was really two forces.
Ooh.
His van der Waals force explained why matter has the ability to be attracted to each other. And the second scientist is Wilhelm Hendrik Hissem. He wrote the first mathematical description of dipole-dipole interactions. He called Hissem interactions, named after himself. And another scientist was Peter J.W. Debye, and he discovered dipole and induced forces in 1912. Another scientist is Fritz London, who came up with the London dispersion forces. And he proposed that force occurs when electrons in a molecule make temporary dipoles that exist only for an instant. He thought that as molecular size increases with more electrons creating temporary dipoles, the strength of the force increases. And the last scientist is Glorietta Linus-Pauling. And he discovered hydrogen bonding in the 1930s.
Cooking, laundry, leave. A modern example of adhesion is capillary action in trees. They use it to get nutrients from the roots up to the leaves. While cohesion is used in examples such as cooking and laundry and swimming.